Hi, ladies and gentlemen. This is another in my series of lessons in uh, different topics that we were covering. This week we're looking at the counting principles. The counting principles are nothing more than a statistical way of saying how we're going to count how many we got. Okay, so let's look at this. Accounting principles, you've got the addition counting principle. You can perform one action or it may use the word or in it. Or you've got a multiplication counting principle. You're performing two or more actions and you got the word and located in it somewhere. Let me give you a couple of examples. You're making a pie and you can choose 1 to 6 fruits and one of 3 pie crusts. How many ways can you make this? You notice this has got the word and in here, right? But if you phrased it differently, if you're making a dessert and you were choosing one of 5 pies or one of 3 cakes, how would you choose a dessert? So you can see it could have both words in it there, right? So up here we're actually making two choices. We're making a choice out of these 6, and then we're making a choice out of these 3. Hmm. Well, how many ways could you make the pie? Well, there's a couple ways of doing this. This one is using the multiplication principle. So you would take 6 times 3 to get 18 different ways of making that cake. Okay? And this one down here, this one's using the addition principle. So you can choose one of 5 pies or one of 3 cakes. So you would add the two of them. 5 plus 3. So you got a choice of 8 possible things that you could choose from. So that's the difference between these two, okay? The words and or basically give you a clue what you're doing. But in the addition principle, you're always doing just one action. And over here, you're actually doing two different things. So you have to keep that in mind. So one of the things we're going to be looking at here are called factorials. Factorials are nothing more than a fancy way of saying how we're going to multiply numbers together. Let me give you an example of a factorial. A factorial for n factorial, would be n times n minus 1 times n minus 2 times n minus 3 times n minus 4 dot 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 all the way down to n times 3 times n times or times 3 times 2 times 1. Okay? Now there's a special case. A 0 factorial is always 1. So you just keep that in mind. If you get a 0 factorial, you just got to make that equal to 1. So let's look at a couple of these and see how they work out. So we got 7 factorial. That's 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, 7 times 6, that's 42. 5 times 4, that's 20. And 3 times 2, that's 6. Well, I can multiply these two together easy enough. That's 120 times 42. Okay, so I take 120 times 42, and let's see here, 0, 4, 2, and 0, 8, 4. Add those together, you get 0, 4, 0, 5. 5,040. Okay, now this one here, this would be 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. Well, that's 20, that's 6. 20 and 6. That's 120 when I multiply those two together. And that's 6 more. And so that's going to be 720. This is the easier ones to do over here. 8 times 7 times, well, I'm just going to write that as 6 factorial because if I'm dividing by 6 factorial, they're going to cancel each other out, aren't they? I could write 6, 5, 4, 3, 2, 1, but I'd have 6, 4, 5, 4, 3, 2, 1 down here, and they would cancel each other out. And so I'm just going to have 7 times 8 up here, which is 56. You guys see how I'm working those factorials out? Let's work one more and see what it looks like. So I got 2 times 8 factorial divided by 12 factorial. Well, let's see here. Doing this quickly. It'd be 2 times, well, since the 8 is the smaller number, I'm going to leave that as 8 factorial on the top. And on bottom, I'm going to say that's 12 times 11 times 10 times 9 times 8 factorial. And those will cancel each other out. Okay, well that's simple enough. I can divide the 2 into the 12 and get a 6 on the bottom, right? So what have I got now? I've got 1 over 6 times 11 times 10 times 9. That's 66 times 90. Okay, well I can do that can't do that one in my head. 66 times 90, 0. 6 times 9 is 54. Carry your 5. That's 54 and 5 is 59. So I get 5,940. So this thing all equals 1 over 5,940. Cool? Okay. Word problems. Samantha can choose to have milk, juice, or tea with her chocolate cake. How many different combinations are there? Well, let's just think about this. We have milk, juice, or tea. Well, that's three things, right? And she's going to eat them with her chocolate cake. So basically, with that or, let's go back up here. What was the or? The or was the addition one, right? So I've got 3 plus 1 would be 4 different combinations. Okay, so that's what we're looking at with the counting principles. I hope you understand this. It's just intended to give you a little bit of help with that topic before you go into it too deeply. Talk to you later.